everyone. Today I am covering the topic circle theorems. Circles have many interesting properties and relationships which are famously called circle theorems. There are 7 circle theorems. Sounds daunting, isn't it? But you will be happy to note that the first 4 theorems mean one and the same. They are actually offshoots of the very first circle theorem. Certain terms need to be known before I explain circle theorems. Here they are. An arc is any part of the circumference. A sector is an area bound by 2 radii and an arc. The smaller one is called the minor sector and the bigger one is called the major sector. A chord is a line segment whose end points lie on the circumference. A segment is an area bound by a chord and an arc. The smaller one is called the minor segment and the bigger one is called the major segment. The first circle theorem states that the angle subtended by an arc at the center is twice that subtended by it at the circumference. Here's the proof. Join CO and extend it to P. Since CO, AO and OB are the radii, we can mark the equal angles of isosceles triangles thus formed as X, X and Y, Y. The exterior angle AOP would be 2x and BOP would be 2y. Hence, the angle at the center AOB would be 2x plus 2y is equal to 2 into x plus y. But angle ACB is x plus y. Hence, it's proved that angle at the center is twice that at the circumference. The second circle theorem states that angles subtended by an arc in the same segment are equal. The proof: let angle ACB be x. Hence, using the first theorem, the angle at the center AOB would be 2x. And if this is 2x, then angle ADB would be x. Hence, it is proved that angles in the same segment are equal. The third circle theorem states that angle in a semicircle is a right angle. You would notice that angle AOB is 180 degree. Hence, using the first theorem, angle ACB would be half of it, which is 90 degree. In order to understand the fourth circle theorem, we need to know what is meant by a cyclic quadrilateral. A cyclic quadrilateral is one whose 4 vertices lie on the circumference of a circle. The fourth circle theorem states that opposite angles of a cyclic quadrilateral add up to 180 degree. Here's the proof. Let angle ADC be x. Hence, using the first theorem, angle AOC would be 2x. Let angle ABC be y. Again using first theorem, the reflex angle AOC would be 2y. Now 2x plus 2y is equal to 360 degree. Hence, x plus y would add up to 180 degree. All this while, we have been confined within the circle. Guys, it's time to venture out of the circle. Firstly, we need to know the definition of a tangent. A tangent is a line that touches the circle at one point. From a point on the circle, one tangent can be drawn, and from a point outside the circle, two tangents can be drawn. Circle theorem 5 states that the angle between the tangent and the radius at the point of contact is 90 degree. The sixth circle theorem states that the tangents drawn from a point outside the circle are equal. The seventh circle theorem states that the angle that a chord makes with the tangent is equal to the angle subtended by the chord in the alternate segment. While solving circle theorem questions, you can give reasons in short using these standard phrases. 1. Angle at the center is twice the angle at the circumference. 2. Angles in the same segment are equal. 3. Angle in a semicircle is 90 degree. 4. Opposite angles of a cyclic quadrilateral add up to 180 degree. 5. Angle between tangent and radius is 90 degree. 6. Tangents from a point outside the circle are equal. 7. Alternate segment theorem. Students often make this careless mistake. They assume a point near the center as the center. So, if angle ABC is given as 63 degree, they wrongly apply the circle theorem and mention angle ADC as 126 degree, double of 63. I have two Venn mantras to offer in circle theorem chapter. The first one, whenever you see radii, mark them as equal. If y is given and x has to be found out, there is no way you can find it unless and until you mark AO and OB as equal, thereby making AOB as an isosceles triangle. Many a times you would be given a mishmash of many angles and triangles. At that time, it becomes very confusing to identify the equal, half and double angles. My second Venn mantra will then come to your rescue. It may sound a bit odd. It says, hold and go back. For the first theorem, hold the arc and go back at the center. Hold the same arc and go back at the circumference. This angle is twice this one. For the second theorem, hold the arc, go back at the circumference. Hold the same arc and go back at another point on the circumference. Both these angles would be equal. For the seventh theorem, chord AB makes an angle with the tangent. Hold the chord and go back in the alternate segment. These two angles would be equal. Now let's apply whatever we have learnt in IGCSE board June 2009 paper 2 question 22. We have to find angles P, Q, R and S. Holding the arc and going back, we get angle P as 58 degree. In order to find angle Q, consider triangle ABD. Angle BAD is 90 degree as it's the angle in the semicircle. Angle DBA is 58 degree, which was given. Hence, angle Q is 180 minus 58 minus 90 is equal to 32 degree. Angle R is the angle which the chord makes with the tangent. We have to just equate it to the angle in the alternate segment. Hence, R is equal to P, which is 58 degree. Finally, to find S, we have to subtract this angle from 90 degree. Now, this angle again is the angle the chord makes with the tangent, which would be equal to 34 plus 32 is equal to 66 degree. Hence, S would be 90 minus 66, which is 24 degree.